Hi everyone, my name is Sarah Hagen. I'm a spatial ecologist with the Nature Conservancy's LANDFIRE team. Today, I'm continuing our video series on universal design and cartography by taking a closer look at how I took a map from this to this by modifying symbology to make it easier for everyone to understand. If you missed the first video in this series, where I gave an introduction to universal design and cartography, I recommend that you click the link on your screen to watch it, or to refresh yourself, as we'll be using a few of the tools I mentioned in that video. Here we are in ArcGIS Pro. I'm using version 3.0, which I highly recommend as they have added in a new color vision simulation tool similar to the one I showed from QGIS in the introduction video. The map on your screen, which is the LANDFIRE Vegetation Departure grid as delivered from LANDFIRE, shows low vegetation departure in shades of green and high vegetation departure in shades of red. This is a standard color scheme we often see, where values deemed good are displayed in green and values deemed bad are displayed in red. If we check this map with our color vision assessment tools, we quickly see that under certain color vision scenarios, it is very difficult to distinguish low departure areas from high departure areas. If I click through these, can you distinguish which areas are good and which are bad? No, which means we have work to do. Universal design aims to design products and environments that are usable by all people to the greatest extent possible without the need for adaptation or specialized design. LANDFIRE shows vegetation departure values from 0 to 100 with one color for each value. This leads to a very long, complicated layer legend, as shown here. It's basically impossible to distinguish a pixel with a value of 20 from a pixel with a value of 19 or 21 at this scale, making the map appear to be separated into distinct categories and not unique values. Therefore, my first recommendation is that we classify the legend. This will make it easier for users to interpret, and it will cut down on the number of colors, thus making it easier for us to reassign color values in the ramp. Because the label and description fields in the original LANDFIRE grid are text fields, we can't easily categorize these data using the classify tools in ArcGIS. To help us, I've reclassified the layer to one that has only numeric values. Let's see what happens when we categorize the data and pick a color scheme that seems more universally accessible, like this brown to green one. Not bad, but we still have a few issues we need to address. Namely, that the original dataset splits out water, snow and ice, urban, barren or sparse vegetation, and agriculture, while this reclassified dataset assigns them numeric values. We don't want those to be captured in our departure classification, so we'll need to do some work to move those into their own categories. Thankfully, LANDFIRE does have standard numeric values for these non-vegetated fields, so I was able to use the LANDFIRE documentation and assign the correct number code to the correct value. 111 for water, 112 for snow and ice, 120 for urban, 132 for barren or sparse, and 180 for agriculture. We'll use these values to modify our classification. To start, I want to assign the last departure value to simply 100, so I'll type that here. Next, we want to take all values from 100 to 111, there should be only one, value 111, and make that its own class. We'll do the same thing for each of these non-vegetated classes, typing the numeric value it has been assigned into the upper field as shown here. If we use the swipe feature, we can see that this map looks largely the same as the original map, just with a different color scheme. Still, it doesn't make sense for water and agriculture to be green, so there's more work we need to do. Let's make the urban values a flat black, which pulls them into the background a bit and almost signifies them as pixels without data, or areas we don't have to worry about in this map. The next thing to address is agriculture. Agricultural land can effectively be classified as 100% departed, so let's copy the hexadecimal code from the 100% departure bin and apply that to agriculture, making those values the same. This looks much better now, but we've still got a pretty major issue. The departure ramp now goes from dark brown to light brown, which indicates that the higher values might be in better condition than the lower ones. That's the opposite of what we want our map to communicate. I propose we go back to a red-green color ramp to better show low departure versus high departure across the area. Now, I hear you all saying, but you told us to avoid red to green color ramps. Here's the good news. We can still use red to green color schemes, as long as we're mindful of a few things. Although the hue is the primary concern for people with color vision deficiency, we can often make colors distinguishable enough by varying the saturation, or how dark the color is. If you have a red and a green and the color saturations are far enough apart, people with deuteranopia and protanopia may be able to see them as two distinct colors. Additionally, if we change the tones enough, we may be able to create reds, greens, and oranges that all look distinct enough to convey the same level of map detail we see in the full color vision scenario to those with color vision deficiencies. This requires some trial and error on your part, and although I'll walk you through that a bit, it's ultimately going to be up to you to change the colors, do some testing, and adjust to create a map that communicates your information clearly to all users. Let's go back to the map. I find it best to start with either red or green and base the rest of your colors around that one, making sure every new color you add is easily distinguished from the one you chose as your base. In our case, I'm going to work with the green first because that is the low departure vegetation, and as conservationists, we're hoping for more pixels in low departure and fewer in high departure. Pick a darkish green and set that as your value for low departure, like so. From there, you effectively build a ramp, so the next value should get a shade of green that is noticeably lighter than the darkest green. We'll choose this one. Now we're at the middle value, so we should shift away from green and into something like yellow. For now, we'll try this one. Now we move into high departure, so we'll test out some orange tones, brown tones, and maybe even a red. Remember that we don't have to get this right on the first try. I'll try this for an orange, and then something like this for a red tone, mostly brown with a reddish hue. Not bad. It's a pretty good looking map, at least to me as someone with full color vision. Our legend is simplified, and we're still seeing the same key patterns we saw in our original data. Let's check it using our color vision simulator tools. Remember, if you're not using ArcGIS Pro, you can use tools like Color Oracle, which you install as an application on your computer and check the screen. I often find this helpful even with the built-in tools, as Color Oracle will change the appearance of the legend as well as the map, so you can double-check that your information is being presented clearly to all users. Using the ArcGIS Pro tools, we can see that our red and green are fine, but the green and orange look far too similar to those with deuteranopia or protanopia. If we want to check some of the nuances, we can zoom into an area that has both the darkest red and the darkest green pixels, and see if we can distinguish them. Not really, so we'll need to make some decisions. In this case, because everything else looks good, I recommend changing your green. We'll want to make it darker, since the second departure category is already a lighter green. To do this, we can either select the next darkest shade in the predefined ArcGIS styles, or we can manually change the hue, the saturation, and/or the value. If you go to the color properties, then at the top change the color mode from RGB to HSV, it will bring up a window that lets you adjust these properties. Because we know that the best way to correct two hues that look similar is to adjust how dark one of them is, we'll look at the value slider. Let's make this green a bit darker by moving the value to the right. How does it look now? Pretty good, but the green is still a bit too close to the orange. We need to go back to our process. I won't show you the whole thing, as it's a lot more back and forth like this until you find a color that looks right across standard color vision and each of our other color vision scenarios. However, the color I landed on eventually is this, which has significantly less red, slightly less green, and is 20 percentage points darker on the value spectrum than our original. Here's what this looks like in standard vision, deuteranopia, and protanopia. A pretty good map all around, and much improved from our original. From here, you should go on to do the rest of the cartography, label the departure classes, make any other adjustments, and you've got a map that's designed with all users in mind. Thanks for watching. Stay tuned in the next video in the series, where we'll take a closer look at color contrast and some tips and tricks for labels in ArcGIS Pro.